I'm also very appreciative to be here and to see a lot of people after a long night yesterday. Was very good though. Thank you very much for the location as well. um, let's start today with another topic about how we can use Python in the geospace and also other tools which come in handy in order to do some use cases. So it's a mouthful of a title. Let me guide you through this. Calculating heat technology transition scenarios. So in Germany, there's a kommunale Wärmeplanung. It's more or less every municipality has to do a heat transition strategy until 2028. The larger ones before that, the smaller ones until 2028. And as DIGICO, we have a modeling solution which helps in order to derive those results and strategies, which I will tell you. And we are very Python native at DIGICO, so we use a lot of Python in order to do this. That's what I'm gonna tell you. And besides the kommunale Wärmeplanung, those heat transitions, we do also have a lot of other use cases which all work in the direction of climate neutral heating, but also mobility and other sectors. So in order to guide you what in general does DigiCo, we start at the bottom. We have our DigiPad, which is what we call Google Maps for municipalities. So kind of a viewer. You can throw in there all different kinds of geodata and you can visualize it. What we start with our customers, we have an extensive database, but we also have the possibility to import real data from customers. This is what we do. So for example, how much gas consumption were there in a certain building or household, or where do you have a district heating network that we can also include in our analysis. Then we do analysis of status quo. So we show how is the current status. We talk to our customers and ask them what kind of parameters do they want to include in the analysis. And we create those analyses in the sectors of energy, mobility, and heat. Today we are going to, I'm going to tell you a use case that we did for E.ON marketing in order to get more attention of German citizens about the kommunale Wärmeplanung and how E.ON is also supporting it. So without further ado, let me start to explain you the use case in general. So basically, why did we do the use case for E.ON and why is it important for E.ON as well? So there's a marketing and communication campaign going on that E.ON is supporting infrastructure invest in order to be able to cope with the additional load, as we have heard yesterday. So for example, if you have your e-mobility, you need to load it via the wall box, or you install a heat pump, you have additional load that you have to cope with. So in order to show and emphasize the role of E.ON, that the distribution of energy is going to be possible and that E.ON is working on it, they want to present it in an interactive manner. How did we do it? So actually we took our results that we have derived for heat transition planning. We have aggregated them on broader level. So we are not showing it on a zip code, on a building level, but on a zip code level and municipality level and state level. And this is also openly available. So every one of you, and I will show you later the application itself, can also navigate to it and see what it looks like. And it shows the status quo about the heating. So what kind of carbon dioxide emissions are there, how much heat demand you have, and so on. What did we do technically? So as I told you, we took all the data on about the buildings. We have 21 million buildings. in Germany that are in our digital twin or our database, and 144 different properties of those buildings. So, for example, the height of the building or the age when it was constructed, or what kind of income the households have in those buildings. And based from this, we calculated different KPIs which can be displayed or were displayed in the map. We also have the possibility to do future forecasts until 2045 on an agent-based model that I will tell you about, which is not present in the application itself because E.ON doesn't want to have an opinion how the development is going to be until 2045 because it's a very delicate matter. What do you get from the application? You get heat insights on a local level, so every citizen can see, for example, in general, in my municipality, in my zip code, do I have a rather higher heat demand and higher emissions than the average in Germany? Or how much money does my surrounding spends in order to create heat, to get heat in the winter, to go through the winter, and to understand the status quo about this. You can see a little bit on the left or on your right how it looks like. You get the data aggregated from 21 million buildings on different levels, and you have the possibility to interactively zoom in into the map, have some different KPIs which are displayed when you click on certain polygons in the map, and the stuff that is displayed is actually, for example, the technology. So, for example, how much gas technology is being used in order to heat your current area of interest, and different other KPIs that I told you about, like CO2 emissions and so on. We also have information about what's renovation status there is about the building, because of course you don't only have to generate the energy, but you also have to isolate your building and so on in order to decrease the demand of energy, which is also displayed how well in your region the renovation status of the building is on average. Before I go further, let me try to demonstrate how it looks like. So, as I told, every one of you can publicly go into the map. I will dive into how we actually host this and so on, but this is how it looks like. So you have a simple map which is created, I think, in React, and we used MapLibre in order to actually create the map. You have all the different states, and you can, for example, click on Bayern. You get KPIs displayed on the left, like the heat demand, CO2 emissions, and those are all the aggregated values for Bayern itself. But what is interesting, you can actually zoom in even further. So we can zoom in to Freiburg, for example, which is not far away. So here, when we zoom in, you can see on a municipality level, you get all the information displayed as well. And this is the Wärmebedarf. You can also switch it here from Wärmebedarf to the pie chart about what technology I used in there. So we can see in Freiburg, for example, we have a dominating heating technology, which is gas. Then there's oil, and the third one is district heating. So we see here a lot of potential that we need to work on, or the citizens actually in Freiburg need to work on, and the municipality has to motivate those citizens in order to, for example, get rid of the gas and oil heating technologies and install, for example, heat pumps, or they need to offer district heating in order to create an alternative for the citizens as well. What is also possible, we can go even deeper. So we can actually have also results on a zip code level. So here you can see different zip codes, and you can get all the information as well. Additionally, let me see. There's also a possibility to search. So for example, I live in Noise. You can search and you can get in there where you live. And this is on a municipality level and also on a zip code level. So this is my zip code in Noise, exactly. So you have also the possibility to very fast find your area of interest and see all the statistics about this. So just a small demonstration how the solution looks like, and now I will get to the whole ecosystem that we have in order to actually be able to create those applications and content which is displayed in those applications. So in general, we are speaking about the Digico ecosystem, which has 4 different pillars. So we have our Digipad, which is Google Maps for municipalities. We have the possibility with the Digipad configurator to provide application that actually provide the possibility to customize your results. So for the heat planning, for example, there are 170 parameters which users can adjust. For example, how much the gas is going to be costing, how high is going to be the price in 2035, or when you're gonna ban the gas technology or oil technology, or you increase the efficiency of the heat pumps. And all those parameters have a certain produce different results, right? So you have different scenarios which you can calculate. For example, like one of the standard scenarios also is all electric scenario, which we calculate. So there you can see like heat pumps are going to be dominating and will have around 90% of total. Then everything that we cannot display in Digipad, we use Digico dashboards, which is used superset. So those are very custom analysis and custom visualization for our customers. This is also, this is all the customer facing application. On the right side is our workbench. So we call it Digico Lab, which consists of different tools where our internal data scientists can work on in order to create those results. This is typically Jupyter Hub, Superset. Now we have Postgres databases and so on, but we are switching to Snowflake, for example, like Airflow, dbt, and so on. So all the tool stack that we are using, this is comprised here on the right side. And of course, we need a lot of data. So 21 million buildings, a lot of open data that we integrate. This is our comprehensive database and possibility to integrate customer data as well. So we provide interfaces to import, but also to export data, raw data, because a lot of customers, for example, don't want to use the Digipad or application that we provide, but they have their own ecosystem and they want to use our results. So we provide data as well if the customer wants to have it. Now I have talked a lot about data. Let me show you an example what we actually have. So here you see on your right side, on your left side, the building and social data. So you can see visualized the polygons and also different properties, and the polygons are colored based on the properties of the data. On the right side, an example of the infrastructure data. So you can see here, this is electric grid infrastructure on a low level that is displayed as well. And our main data supplier is Nexiga. So we actually buy proprietary data and integrate even more data on top of it. But this is like the basis, and they buy data from different data providers as well. So for example, also from the Deutsche Post or Deutsche Telekom in Germany, if you use the Immobilien Scout and you want to advertise your building, then the data is being collected and resold as well. So yeah, just maybe two things. First, if you have a cool use case and you think you don't have the data, just maybe think about the use case. There's definitely somewhere data about this. And the second one, there's nothing for free. So if you use any free services on the internet, be sure that your data is being collected and resold. So be aware of the small print which you have in there. And yeah, companies like Nixiga is making use of it, and actually the data that we are buying costs a lot of money. I can tell you that. But to the positive side, those are different areas and different analysis that we do, and some examples for this, how we can actually use the data. We have areas of potential. So actually we look in whole Germany, we look for potentials and potential regions where we can install district heating. So for example, one of the customers from Eastern Germany asked us, we have 1,000 municipalities and we have only money for around like 10 to 15 district heating solutions. So what are the most promising regions where we can install the district heating? So for example, we did an analysis where you have the like high heat density areas where you don't have already a heating solution or a district heating solution, where the renovation rate is very low. It doesn't really, you cannot really install heat pumps without a lot of invest from the citizen side. And you know, this different rule-based solutions actually, which we discuss with our customers, provide the results which help them in order to create their own use cases. Or the heat pump modeling that was presented yesterday, where you can install the heat pump in an optimal way. But also what we did here was individual analysis. So actually, E.ON didn't want to have any predefined data product from our side, but wanted to have a custom analysis which we created for them. How did we do it? So this is our general approach, and the best way is to start on the left top with the inventory assessment. So actually, before we start any modeling and so on, we look at the data which is available there in our database. Then we integrate data from our customer. We look at the heat demand which is there, and the heating capacity which needs to be done, and the renovation status and so on. So just the status quo, which was also used and is displayed in the E.ON interactive map. Furthermore, the possibilities to create different scenarios. So this is really the modeling step in an agent-based model. So each household of those 21 million households is an independent agent which can decide every year, do I want to renovate my house or not? Do I want to take and buy a new heating solution or not? And this is done for all the years until 2045 or 2050, depends on the custom demand of the customer. And you have the possibility, as I told you before, to actually create your own scenario. So you can say, for example, our electricity is going to drop in price from like 30 cents per kilowatt hour to, for example, 15 cents, because will have a lot of green energy generation and so on, or it's gonna increase because we're not gonna be able to do so, and we still need to rely on gas in order to generate electricity. So a lot of different possibilities to actually interact and create your custom scenarios. The modeling step is, as I told you, agent-based decision. When do I want to renovate? When do I want to switch to a new heating technology? And then the question is, what heating technology am I gonna be using? And for that matter, we are optimizing on a cost parameter. So we want to make the transition for the citizens as simple and as affordable as possible. So that's why we actually only optimize on a cost level. And after the results are created, we have different dashboards which we display the results in, but also a very simple PowerPoint which we can actually send to our potential customers even for free, in order for them to get like an opportunity to see what they will get. But this is like a standardized report so they get a feel. Now let me dive into the modeling step itself. So there are two different steps. The first step is always to decide what households are going to be actually replacing the heating solution. And this is determined via different rules, but also a weighted approach. And there are different properties that we look at. So, for example, what is the income? Um, how new or how old is the heating solution? So, for example, nobody is going to throw away a heating solution which is only 5 years old, but this is much more probable if it's 30 years old. What restrictions do I have there? So, for example, there was a lot of talk in Germany, at least, that the heating police is gonna get to your house, gonna rip off the gas heating technology, and you need to install another one. This is not what actually is going to be happening, but a lot of people were afraid that is going to be done. This is something that we can also simulate if needed. Here you can see the real weights that we use actually to decide who is going to be renovating or installing a new heating solution. So the most weight is going to technical factors like heating system age, renovation status, and condition of the property. So where you live, does it belong to you, or are you only renting the place out? Economic factors, you need money in order to buy a new heating solution, and also heating costs. So if you have a very inefficient solution, you're more likely to get a new one which is more cost effective. Socioeconomic factors, and the last one might be surprising, but actually a lot of people talk about ecological factors, but if you don't have the money and the possibility, then yeah, you can only talk about this, but you cannot actually afford to buy an EV and a new heat pump and renovate your house and so on. I'm gonna skip this. Here's some more details. So I have talked about the 21 million buildings that we have, that we buy, but what we actually also do, we get a lot of open source data and try to improve the results, but also get a more coverage. So it is believed that we have around 28 million buildings actually in Germany that we need to simulate, and we only have 21 million buildings in our database, so we are missing 7 million buildings, and this is something that we want to and getting from open source. So for example, the polygons from OSM, the properties from census, and other different openly available data sources. Yeah, we calculate the missing data, we enhance, and so we need also to calculate the properties, and the most important part for us, also quality assurance. So a lot of our customers, they have the possibility to look on a building level, and you can imagine if you have this possibility, you go to exactly your house and you say, wait a second, I don't have a gas heating solution because last year I have bought a new one. I have bought a heat pump. But of course, our data is not that great on the building level. So you have a lot of talk about, data quality and how precise the data is and so on. And yeah, we try to be as good as possible. But of course, on a building level, this is very, very difficult. Just a small overview how we actually deal with data at this point. So we work completely on Azure. We have provisioning with Terraform. So we actually have our platform as a code solution, so we can rebuild it if necessary. But the important part is actually in the middle. So we provide the possibility to our customers to get their data on blob storages, or we can connect to their APIs. Then typically in ALT manner, we use dbt, custom EL containers. So here you can see GeoPandas. We're also using OGR to OGR and different tools depending on the use case. Right now, the orchestration is done in Argo workflows, and everything, by the way, is in Kubernetes. We have now a new project where we will switch actually to airflow for this manner, but else is going to stay more or less the same. We're storing the data in Postgres with Postgres extension right now. Here we are going to be switching to Snowflake in order to get more support, and hopefully also more performance. Let's see. Prep and modeling, we have our own Jupyter Hub instances and Superset in order to visualize the data. And exactly for the use case with the Eon interactive map, what we have done is actually we have queried the socioeconomic database, which is on Postgre. We have created the heat concepts in Jupyter Hub, stored the results in Postgre. Again, we have used Martin tile server in order to connect to the Postgre and provide the tiles for the map that you can see. Location IQ as a service for search capabilities. First, we had our own solution, but it was not working that great, so we actually switched to Location IQ instead. And the base map is used from Mapbox, which we cache in order to provide greater performance. So the map that you can see should withstand 5,000 users simultaneously. Right, and the front end, yeah, it's coded in JavaScript and TypeScript. And as I told you, MapLibs was also used. And to scare you off a little bit, hopefully, this is actually like a small overview of our Azure infrastructure. And you can see a little bit with the boxes on the left side, Eon and Wärmekarte going into the middle with the Wärmekampagne front service and Martin tile server with different services connected. So the part that we actually did for Eon is around like 5% of the total infrastructure that we are deploying and using on an everyday basis. Thank you very much.
Thank you very much. Are there any questions? There's a question on the left side here from my point of view. Okay.
Thanks, Michael, for a very comprehensive presentation. So I'm from Denmark and also work with renewables and wind energy and the whole complex energy systems. So I'm a little worried about what I'm seeing in Germany with all the gas and oil that you're still consuming. And also,
me too.
yeah. And so like it's the great agenda with the Wärmewende is perfect. But I think with your tool here, I'm a little worried about it's a decision support tool as I understand it. And it's also a lot of it is on the individual agents that they need to decide themselves in the individual home what they want to transfer into, whether it'll be a heat pump, which would be an individual one, or the better solution as I see it, the district heating. So how do you model that? So because you need some way of modeling this for the larger areas that you are doing, because if you have too many people in a specific municipality or smaller area that'll go for individual solutions, then there's no business case for the district heating, which is much more flexible in the long run.
Definitely, so I can agree. First, I can agree on the problem that we see. A lot of fossil fuel is used even now and in the next years, to be honest. We also see the greatest potential in order to combat it, not only to provide the information to the citizens, hey, just buy a heat pump, right? No, the solution is actually, or the problem is, we have the Stadtwerke, so the utility companies which rely on infrastructure in order to get some money. Actually, they earn money by selling gas, for example. Now, after we do the analysis, we show them, well, you know, in 2035 or 2040, you're going to have a problem because like half of your consumers are going to switch to a heat pump. So they're not going to be consuming gas. Your infrastructure is not going to be self-reliable. You're not going to earn money with it. You're going to lose money. So, instead of only investing in FTTX in order to get some additional income, think about district heating solutions, and you don't have to do large ones, but do smaller ones. So this is what we are talking about. Now, on the modeling side, we don't have right now the option to actually model the district heating solutions like automatically. So this is still an individual analysis. So what we do, we create those scenarios, we have the data, and we still see, okay, where is the highest potential? Where do people switch mostly from gas, for example, to a heat pump? And there we go to this area and say, okay, here you have a potential like for a small district heating solution. Please, utility company, look at this, do some calculations, talk to engineers if it's like feasible and cost effective and so on. So we push them in the right direction, but we get also, to be honest, a lot of pushback because who is paying us? The people and departments who earn money. Who earns money there? The people who sell fossil fuels, right? And they're interested in actually sticking to the gas infrastructure and still get their income. Yeah, so it's difficult.
There is another question. 1 second, almost there.
It's not a question, it's just an FYI. We have another talk before lunch that actually focuses on district heating and there's a POC that we derived on where to build new district heating networks. So if you're interested in that, come to that talk, a little advertisement.
Okay, great. So last chance for a question. If not, we still have the coffee break afterwards. And thank you very much again, Michael.
Thank you.